These are the notes for standard 3.1, which concern drawing force diagrams. Since Unit 3 is all about forces, we should define what a force is. A force is an interaction, like a push or a pull, between two objects. We're going to try to describe these interactions on force diagrams, and in order to do that, the first step is to draw an arrow that points in the direction that the force is applied, and then the second step is to label the force with the following notation. Now, this may look complex, but it actually allows us to communicate quite a bit of information in not a lot of space. So all forces are going to be labeled with a capital F for force. Then we're going to use a subscript in order to tell what type of force we're discussing, and we will talk about the most common types within the slideshow. And then we'll use parentheses to list what object is being acted on by the force, and then which object is the force coming from. So over here we can see that there's a force acting on this stroller. And so we have a capital F for force. The type of force is a pushing force. And then the force is acting on the stroller, and it's being provided by the Lego dad. And so all of this helps us to know lots of information about that specific force. Gravitational force is the most common force on our force diagrams and in this unit. Gravitational force is due to the interaction of two objects with mass. And really, we're going to focus on the gravitational force that is felt by being close to a really massive object, which is Earth. Gravitational force pulls us in the direction of the center of the Earth. And so in most of our problems, this is going to be an arrow that's straight down. And it's the only force that can affect objects that aren't touching, at least the only force that we're going to talk about in this unit. And so even an object like the one shown on the right here, even an object that's not directly touching the Earth, it's still affected by the gravitational force provided by Earth. And so we see the arrows pointed towards the middle of Earth. It's acting on the Lego, and it's being provided by this massive object. Also, the subscript is just a lowercase g. Normal force is caused by a surface pushing on another object. Normal force will only exist when two objects are in contact with each other. And the word normal actually doesn't describe how common this force is, but instead it describes that the direction of the force, which is in this example straight up and down, it is perpendicular to the surface that's providing that force. Because normal is another way to say perpendicular. We describe normal forces with a capital N as a subscript on our F for force. And this is anytime one object pushes on another object. Tension force is caused by one object pulling on another object. Tension force usually relies on ropes, strings, chains, or cables. It will always point in the direction that the object is being pulled. And so here, the chain is providing a tension force on the Lego toy. We represent tension force with a capital T as the subscript on our capital F for force. And then the last type of force that we're going to talk about today is friction force, which is due to surfaces of two objects rubbing against one another. Friction force resists the motion of an object, and so it acts in the opposite direction of the object's motion or intended motion. And so in this example, the car is moving to the left, and therefore the friction between the car and the ground is going to counteract that, and it's going to push or pull on the car to the right. Even if this car wasn't moving, but let's say someone was in front of it and pulling on the car to go to the left, friction can even happen before the car starts to move, but just as a result of its intention to move. And so just by something trying to move to the left, it could experience a friction force to the right, or whatever the opposite direction of its intended motion is. And so we can take all these forces, and if we see them all acting on the same object at the same time, it can become quite overwhelming to consider all of them at the same time and see what their effects are on each other and overall on the object. And so instead of looking at them kind of all positioned around a picture, like is shown here in this free body diagram, what we're going to focus on instead is drawing force diagrams. And so what a force diagram does is it takes whatever object that we're considering and it shrinks it down to just one point or one dot. And then we draw all of the forces acting on that object with the tail of the arrow on the dot. And so here, by showing all the different forces acting on the Lego and in what direction they're acting, eventually we'll be able to include the strength of these forces, and then this will allow us to make predictions about how the object will move as a result of the forces. Thank you very much for watching.